Here we take a look at the Doppler effect. A car is going to be moving across the screen, putting out a sound, and imagine yourself being right here where the cursor pointer is, listening to the sound the car makes. As the car approaches you, you hear a higher frequency pitch, and as the car goes away from you, the pitch is lower or a lower frequency. Here's the sound. That's the Doppler effect. The Doppler effect is essentially a shift in frequency due to the relative motion of the source of the sound and the observer. The Doppler effect doesn't just work for sound waves, but it also works for radio waves or all waves, water waves, any electromagnetic wave, whether it's microwaves or radar or visible light. And the idea is that as the source moves, the wavelength crumples up in front of the source and the wavelength expands behind the source. So if you're if you're in front, right here, you hear a higher pitched sound. And if you're back here, as the source moves away, the frequency is a lower frequency. In meteorology, we use the Doppler radar for measuring rainfall. Actually, conventional radar works in much the same that Doppler radar works for measuring the amount of rainfall in the atmosphere, or the amount of precipitation in the atmosphere. The transmitter, the radar station, sends out a radio wave, and it bounces off all of the precipitation that's in the atmosphere. The stronger the intensity of that reflected radiation, the more rainfall there is. And we can calibrate the Doppler radar signal by looking at rain gauges, looking at the actual precipitation to get an idea of what the area precipitation is from the radar signal. Now, the Doppler effect, the shift in frequency, is used to determine how fast the storm is moving away from you or towards you. If the storm is moving away from you, then the frequency of the reflected radiation, the reflected radar signal, is a lower frequency than the transmitted radar signal. And if the storm is moving towards you, the frequency is a higher. The frequency of the reflected radiation is a higher pitch or higher frequency than the transmitted signal. And that's how a Doppler radar is used to determine the velocity of the storm movement, either away from or towards you.